So the topic of today's webinar is about securing JavaScript and Go code with insights and analytics. So before we dive too much into security, I wanted to just briefly go over what a typical developer workflow looks like. So as Ryan mentioned, I'm a developer at Shift Left, and I work with the Go and JavaScript teams. At Shift Left, our typical developer workflow includes CI/CD. We use Git for source control, and we use GitHub to do all of our collaboration. And this is the typical kind of workflow you would see at teams these days. And usually what we see is, you have some sort of main branch. This is where the code that you release to production is going to be. It's typically versioned, and you probably merge things into master as features are completed. But when you're doing development work as an individual, you'll typically branch off into your own branch. You'll push some commits, and that's where the code review happens. And once that feature or bug fix or whatever is complete, you'll merge it back into the main branch so that's ready to deploy to production or staging or whatever. So that's the typical workflow. And as developers, we're used to having things like linting and formatting checks. This is where build and compilation happens. This is where we're used to seeing unit tests run. Now, of course, you'll have some things run locally, but the majority of those kinds of tools will be running in a CI/CD environment whenever you push. So as a developer, I have the expectation that any sort of code scanning solution is integrated with this sort of workflow and into my CI/CD pipeline. That's just what I expect, and that's what my existing tools do. And as a result, if I have some sort of new security solution, that's really where I want it to fall in. I don't want to sort of have to take my artifacts and send them to another service, or manually run something every once in a while. I kind of expect everything to run on every push in my CI/CD. And I don't think that's just an expectation. It's actually, one of the critical requirements for security these days. It must be integrated into this workflow, because if it's not, that means problems aren't fixed as soon as they're introduced. If you're not scanning for security vulnerabilities on every push, that means it's happening way after the code's already merged in, and it might already be deployed before you even notice these security issues. And just like bugs, vulnerabilities are much more difficult to fix the longer they exist in a code base. If I'm a developer and I'm not aware of a bug until months or years after it's introduced, it gets much harder for me to fix that bug, because there might be more code surrounding it. It might be integrated into different libraries and services. There's more tight coupling, and it could be as simple as I forget the context around when that code was written. And so it's really important to fix vulnerabilities and other security issues as soon as they're detected, because that's the fastest way to remediate those issues. So I'm going to jump into a demo here just to show you an example of how easy it is to integrate code scanning into a Go and JavaScript workflow. So here I have a Go application. So this is one of our sample applications that's sort of riddled with security vulnerabilities. And if I jump into the GitHub workflow here, the GitHub action workflow, so this is an example of a typical CI/CD sort of environment. This is using GitHub Actions. And I have a section in here that actually builds the Go code. And similarly, right below that, I have just one line that runs a security scan. So just like, Go build, um, running a security scan using shift left is just as simple as running SLAnalyze, and then there's some other parameters to set that up. So to give you an example of how I would go about using this in a real sort of example, let me jump in here and update some code here. So just like the Git based workflow I talked about earlier, I'm just going to go ahead and edit this file. So I'm just going to make a simple change here. I have this log line that I don't want anymore. So I'm going to make a new branch with this code change and then create a pull request. Now, as soon as I did that, I'll have an action that runs here. And now this could be similar to, a unit test that would run or a linting process that would run. But in this case, it's a security scan. And while this is running, I'll jump back to the slides and show you, explain what's actually happening in the background. So what's happening is shift left is taking our source code and converting it into a code property graph. So this code property graph is a combination of the abstract syntax tree, a control flow graph, and a data flow graph. And this combination of different data structures allows us to have a structured representation of the code. And then shift left will go ahead and run queries on this graph to find security vulnerabilities. Now, in that couple of minutes that it took to explain this, if I jump back into the GitHub workspace here, you'll see that the shift left static analysis has already completed. So in the time that it took to explain that, it's already built that code property graph. It's uploaded to the shift left dashboard, and then we have the scan results already. And if I jump back into the dashboard here, here's my shift left Go demo application. And I see that there's a brand new scan that just completed. And I removed a line that was logging some sensitive data. And that's why we see this one fixed finding here. And if I click on that, you'll see that there's a sensitive data leak that's been fixed. Now I'll go ahead and merge this. And then this will kick off another scan because it's been merged into the master branch. So this is really easy. This is, a typical example of the kind of workflow that I deal with every day, working on code for shift left. And because it's so simple and sort of the exact same workflow that I'm used to, it's the code scanning is sort of on par with my development frequency. And what we've noticed with our customers is that they see an increase of security scanning in their organizations by orders of magnitude. And this is because the legacy tools that they're used to are kind of too slow. They're not integrated into their CI/CD pipelines. And so they're probably scanning, once every release or once every, week or month or so. So with ease of scanning and ease of integration comes increased scanning frequency. And with more frequency comes insights. Basically, with more scans, you're getting more data points and the more obvious trends become. And before I go further, I just wanted to give a demo of how easy it is to scan JavaScript code. It's pretty much the same as the Go version. So if I jump into my JavaScript demo here, again, I have a similar sort of project. It's a Node.js application. It has some vulnerabilities built into it. And similarly, I have pretty much the exact same workflow for GitHub Actions. I don't have a build line here, but if you look at the SL analysis command here, it's pretty much the same thing. The only thing that's different is a couple of things that refer to JavaScript and the application name. So again, what I'm going to do is jump into one of these files. Let's take a look at this one. So before, let's see. Let's find an interesting line here. Okay, so here we have the sensitive data leak. I'm logging some credit card information that I shouldn't be. Let me go ahead and comment that out. Okay, so I have this code change. I'm going to make a new branch. Create that pull request. And as soon as I do that, I have this action that runs. Again, this could be alongside other build tools, other linting functions, maybe code coverage tools. And you can run all of these in parallel, so it really shouldn't take too much more time than you're used to. So I see this running here, and I also see this running in my dashboard. So while that runs, I wanted to quickly give an example of what the results look like. So here, if I click on, let's say, critical vulnerabilities here, here's a different sensitive data leak. And you can see that I have some sensitive data like the username, an API key being logged to the console. Okay, so this is almost done. And that's it. So with high frequency security scans and trends coming from those results, we can ask interesting questions that go beyond just fixing individual vulnerabilities. For example, if you have an organization that's scanning all of these pushes in several different applications, you might wonder as a manager or a security executive, which of my applications are responsible for the most security findings? And questions like, are the number of critical vulnerabilities decreasing over time? If you're introducing a new security scanning tool, are the findings that it's finding actually getting resolved? So let me jump into how we can look at that in Shift Left. So there's this reporting tab, and this goes beyond just simple lists of findings. We can actually see trends over time. So I've actually been scanning those the Go and JavaScript applications on a daily basis for the past few days. And now you can kind of see the trends of these security results over time. So I started, early last month, and we can see that the initial results were pretty high. And then I went ahead and solved a few of those issues, and you can see that the trend dropped. And then I actually reverted a couple of those changes and introduced a new vulnerability. And so the trend went back up again. And we can see that, overall, the total number of findings has decreased because I did fix some vulnerabilities in the JavaScript application. Um, and the number of critical vulnerabilities also decreased. Now, what's interesting to note is that this is only looking at results for the master branch. If I click on this gear icon here, I've only selected the master branch for this view because I'm not worried about, individual findings that are introduced as I'm developing my code. If I introduce a SQL injection as I'm working on a feature, it's only in my feature branch, and that's okay because I'll notice it as I submit my pull request, and then I'll fix it before it's ever merged in. So I'm not worried about, vulnerabilities that get introduced and fixed um, as part of my, regular work. I'm only interested in the vulnerabilities that get merged into master because these are the ones that potentially go out to production. And of course, it's only, and I can use this for multiple applications. I can pick and choose, just the applications that are relevant to my team. I can compare, it looks like the JavaScript application has way fewer vulnerabilities than the Go version. And if I'm interested in the results that I'm looking at, I can go ahead and export these as a PDF or an HTML. And if I'm really interested in certain types of vulnerabilities, I can filter by category and also the type of finding. So let's say, you're looking at all of these things and saying, okay, well, I have all these results, um, and the number of security issues are going up. Now, what am I going to do? Now, of course, you can just fix all of those issues, but that's more of a one-off solution. So what are some long-term action items that you can take? Well, I have a couple of possible ideas. So the first idea is to introduce build rules. So this is a concept that's very similar to, failing unit tests. As a developer, if I have unit tests and I write some new feature that breaks some other feature, those unit tests will catch that and break the build. That's going to prevent me from merging into master and causing all sorts of product issues. With build rules in shift left, you can sort of treat security vulnerabilities as failing test cases. So you can set up a build rule that says, I don't want any SQL injections to be introduced into my master branch, or I don't want any sensitive data leaks to be introduced. It could be as broad as, I don't want any new finding introduced in a pull request. And so adding these sorts of build rules will prevent new findings from ever making it into the master branch. And so this is, a really aggressive way to make sure vulnerability trends never go up. But that's also sort of it's also not really solving the root cause of these security issues. So I would suggest the alternative is developer training and awareness. This is going beyond just fixing vulnerabilities as you find them. It actually encourages secure coding from the beginning. So using things like the OWASP top 10 and other security training can actually, change your development culture and produce secure code from the beginning. So what comes after that? I think, the frequency of code scanning is at a level that we haven't seen before. Solutions like shift left are really so fast that we're scanning code more frequently than ever. And from this frequency comes this insight and looking at vulnerability trends over time. And it's just going to get more advanced from there. I think we're going to start seeing more analytics on top of more frequent code scanning. And we'll start to see more metrics like, mean time to resolution for findings, and looking at broader trends across applications, and yeah, and whatever our customers are going to suggest. And that's all of the content that I had.